Welcome everyone to today's webinar. I'm going to be talking about how to approach coding interviews from the perspective of the interviewer. So when I talk about interviewers, I'm talking about both recruiters and the technical interviewers that you may get during a coding interview. So I'm really excited to start this webinar in collaboration with HackerEarth. HackerEarth has been a great partner to work with. I'm thrilled to share some of this knowledge with you on what recruiters want to see during the coding interviews. And we're going to dive into what I personally look for in technical interviews. I'll give a little bit about myself in a bit. And I really want to help you guys figure out how to best demonstrate your coding abilities and your personality during these coding interviews. They can be tough, they can be stressful, but I'm going to share some tips that'll hopefully make it much easier for you. The goal is, of course, to maximize your chances of getting that awesome software engineering job that you've always wanted. So without further ado, let's begin. So what are we going to cover today? There's three main things. Obviously, technical interviews are an extremely large topic. If you go to any Hacker News or any Reddit thread on technical interviews, particularly on Whiteboard, algorithm, and data structure interviews, you're going to find so many different opinions on whether they're good, whether they're bad, and how to maximize your presentation during the interviews. But today I want to focus on the positives. I want to help you guys get into the head of these companies and really understand why they use these kinds of whiteboard interviews. Obviously, as I said before, data structures and algorithms there's a love-hate relationship among most software engineers with them, but I'll try to explain the argument for them and understand why big companies really enjoy using them, and in fact, why they have to use them in certain instances. After we talk about why companies love using whiteboard interviews, we're going to talk about the things that they're looking for during those interviews. So we'll dive into the exact traits, skills, and qualities that interviewers are looking for. So these traits, skills, and qualities, we're going to call them signals. And we're going to talk about what signals the person on the other side of the table is looking for as they watch you either write up the algorithm or as they watch you respond to their behavioral questions. And finally, once we understand why companies use these interviews and what interviewers are looking for during the actual interviews, we're going to talk about techniques and tips that make sure you're displaying your best attributes and the perfect signals that they want to see during your time at their offices or in conversation with them. So we're really going to talk about all three of these things step by step. So who am I and why are you listening to me? My name is Jacob Zhang, but please call me Jake. I've been a software engineer for just under a decade at this point and have worked at multiple companies in both small and large sized categories. I've worked at startups. I've worked at several companies that you guys will definitely have heard of. And I think that I'm qualified to speak on this topic, being on both sides of the table. I've been interviewed as a software engineer and have interviewed software engineers hundreds of times at this point. In addition, I now share my knowledge from those experiences being interviewed and interviewing software engineers at a site called AlgoDaily.com. And AlgoDaily.com hopes to be the most comprehensive guide to cracking coding interviews. We really try to emphasize visual learning and understanding coding patterns and really learning those patterns to most efficiently practice for software engineering interviews. But today, let's talk about why big software companies in particular and the brand name top software companies like Google, Facebook, Uber, why they conduct such interviews. It seems like no one likes whiteboard algorithmic interviews. So why put software engineers through them? If you talk to any software engineer about whiteboard interviews, you'll get tons of negative feedback. They appear inconsistent, they appear random, they seem to be a poor measure of engineering ability and are obviously incredibly draining. You're usually standing there, getting judged by some tight-lipped senior engineer as you stumble through a problem. And it just feels very strained and foreign. Uh, in fact, sometimes you'll get asked an easy question like how to reverse an array, which may take 10 minutes to solve. And other times you'll get asked to figure out a tough dynamic programming question that involves union find on a graph, which might take somewhere from an hour to 2 hours to solve. So it seems to be pure luck. So why do companies like these interviews? Before we answer that question, let's make sure we're talking about the same thing. So what do these interviews consist of? Let's really understand how they look. So we all know that interviews look a lot like a sales funnel. There's a recruiting funnel. Let's concentrate on these three aspects of the funnel. So there's a recruiter phone screen, which is basically trying to figure out if you're a normal person who can communicate well. And the recruiter is really trying to understand if they put you through a technical phone screen, will you have a chance at passing the technical phone screen? They really want to make sure that there's a fundamental basic fit involved. Is there anything that is on your resume that stands out that you want to talk about? Can this person communicate well? So these are the things that a recruiter will focus on during the phone screen. Then there's usually a technical phone screen. So the question on this that the technical phone screen interviewer is trying to address is really, if I send this person on site, will it be a complete waste of time? So when I'm interviewing a person over the phone, I'm really trying to figure out if it's valuable enough to have anywhere between 4 to 8 engineer hours spent on this person to possibly get them to join our team. If it doesn't make sense, then it's a waste of 4 to 8 engineering hours, which, as we all know, is very expensive nowadays. And then once you make it on site, that's where we're really going to focus. That's the area that we're really going to focus on today, are these on-site whiteboarding interviews. So usually they consist of 2 data structures and algorithm interviews. They consist of typically 1 system design interview where you are focusing on the architecture or the design of an application or a tool. And nowadays I see a lot of front end and UX interviews, but we'll be focusing on the data structures and algorithms one. So with regards to the recruiter phone screen, that's really a behavioral interview where they're looking for not your technical ability, but your ability to communicate and articulate your past experience. There's already a ton of literature on the recruiter phone screen, and we'll cover some tips later to help you improve that skill. But the quick and dirty is really to make it conversational and just enjoy that. The technical phone screens and the on-site are where you really should practice and rehearse even more. So let's go back to why the companies love these kinds of interviews. Here's part of the reason. Large software companies need to hire lots of engineers extremely fast. Let's take a look at this quote from 2014. In 2014, Google indicated it had 2.5 million applicants per year, and it had acceptance rates between 0.2% and 0.5%. So that's a lot of engineers that they are going to have to hire. That was 2014 as well. In this year, 2019, it's surely doubled or tripled at this point. I couldn't find numbers reflecting this year's candidates, but I included a LinkedIn screenshot from just earlier this week. And earlier this week, Google had 186,686 employees. So the only way that a company like Google is going to be able to get through all these applicants in a fair manner is to standardize the interview process. And that standardization may be painful, but it's actually not as bad for the reasons that we're about to explain. So people who are uncomfortable with the state of technical interviewing should consider other industries. So before you read the quote that's on the screen right now, I want to tell you a story about my past life. Before I became a software engineer, I was very interested in going to law school, and I did a lot of research into law firm recruiting and law school recruiting. And in law, As opposed to software engineering, you're almost judged entirely by your resume. So the brand name of the law school you attended, your GPA, the brand of the law firms you previously worked at were the only things that mattered when it came to law firm recruiting. So at least on the tech side, in software engineering, there is an element of meritocracy where if you are a talented engineer, there's some attempt to ensure that your talent is evaluated fairly. Obviously, this doesn't mean we're perfect. So on the screen right now is a real quote from Hacker News talking about how challenging it is for interviewers to hire. So the quote reads, "I just had to conduct a round of interviews in a large US city, and it was a hellish crapshoot. Resumes are meaningless and are often rewritten by recruiters to match the job anyway. Everyone has the same answers to the stupid behavioral questions. And with regards to the code, we included what we thought was a trivial nested for loop problem, and virtually nobody could even get started on it." The reason I'm sharing this with you is because I want you to understand that as an interviewer, I want you to do well in this interview. I'm not trying to go out of my way to scare you or to intimidate you. Interviewing software engineers and finding software engineering talent is genuinely very difficult. And we're not trying to scare you by giving you these problems. This is just the most systematic way that big companies can hire can hire engineers at a rate that is acceptable while also being as fair as possible. And what you want to remember from this slide in particular is that the interviewer wants you to do well. And so later when we talk about collaborating with the interviewer, you should really keep that in mind. So given what we've seen, let's summarize. As a big company, you have the following needs. You need to hire fast in the thousands of engineers annually. You have tons of project demands. So if you need to ship something next quarter or in 2 quarters, you can't wait for good engineers and candidates to show up at your doorstep. You need to hire quickly and you need to evaluate candidates really quickly. And then the last thing that we haven't touched upon yet is you need to be agnostic to a candidate's past. So what does this mean? This means that software engineers come from many different backgrounds. I used the example of law firms earlier. Everybody in the United States goes to law school and then passes the bar and then becomes a lawyer. This is not true for software engineers. Software engineers come from many different backgrounds. Some are front-end developers, others are mobile. Some work on embedded systems. Some work on instruction sets, abstractions that may be high or low. So there's not really a common skill set where you can evaluate 100,000 engineers all in one shot. The only thing that's common to all of them are computer science fundamentals. And as a result, you'll see a lot of data structure and algorithm interviews because they are fundamental to all parts of computer science. So obviously, we understand now why companies do this. But what about losing out on great candidates, on talented engineers who might have stumbled upon a bad interview question or a bad interviewer and don't make it through? So we call these false negatives, and it's fine for the most part. At the scale that Google, Facebook, Amazon, these companies are hiring at, they don't really care if they lose 1 or 2 or even like hundreds of really solid engineering candidates, as long as they prevent 1 or 2 or a dozen or hundreds of bad engineers from getting into their company. So to summarize why companies use this interview format, it's all about scale. There's multiple reasons. It's very easy to train interviewers on data structures and algorithms, which are a shared skill set and common knowledge for all software engineers, mobile, embedded systems, backend. You all have to learn computer science fundamentals, and especially data structures and algorithms at a certain point in time. It's very easy to evaluate and compare candidates with this standardized format. So if we ask 100 candidates the same algorithm question, we can evaluate how they're performing against each other rather than evaluating each interview on its own merit. And finally, it's easy to standardize the process quickly. At a large company, you're trying to hire fast and you have tons of projects that need to be shipped quickly. And so standardizing the process is really easy. You decide on one or two algorithm questions that are asked, and everyone can go ask that question. Or you have a bank, usually an interview bank that companies maintain, where with anywhere from a dozen to hundreds of questions that are suitable for the interviewer. But regardless, still makes the process really, really easy. So now we know why software companies love these kinds of questions. Let's talk about what they're looking for, which is really why you're here today. So what are the traits and attributes that they want to see? So let's get one thing out of the way. It's definitely not for you to memorize solutions. And we'll talk a little bit more about why that's not the case. But beyond memorization of solutions, the reason why you don't want to do that is if we get to a question too fast, if you get to a solution too fast, we're inclined to believe that you've seen it before, and we're going to ask you another question. So one of the things that they're looking for is this problem-solving ability, which we're going to touch upon in a little bit. But just keep in mind that memorizing solutions is not the way to go. And I'll tell you what is the way to go. Before we jump into anything else, I just want to make it very clear that you can get better at these interviews. My philosophy on interviewing strategy and interviewing prep, and this is what I tell everybody who goes on algodaily.com or asks for advice on succeeding in software interviews. You can get better. So you should practice for these interviews, and you can improve much quicker than you think. Many people go from not knowing data structures and algorithms to getting very good at them over the course of a month to a year, depending on experience level. So a pro tip here is you want to make sure that you're scheduling the companies that you really desire towards the end, and the lukewarm companies that you don't really, or obviously you should care about every company, but the companies that are less interesting to you personally, you should probably put in front so you get that practice, because you will get better as you interview more. So here's where we touch upon what I'm looking for and what interviewers are looking for during coding interviews. So the question we're really trying to answer is, and this is the overarching question, is will this person be technically helpful on my software engineering team? So what we really want to know is, if we're stuck on a problem at work, can we brainstorm and work together with you to solve it at work? There's been tons of times where I'm coding something up and I'll get stuck. And the reason my teammates have been hired is because we've put them through a very similar situation where we're given a problem. It's just me and the other person, and we need to come up with a good solution. So let's talk about these three different components of the technical bar. So first is whiteboard / problem solving. Given this candidate a problem and a whiteboard, will we be able to come up with good solutions? Can they talk about big O notation? This is extremely important at large companies in particular, because they have a lot of scaling concerns. When you're operating at millions of requests or billions of requests in a given time period, you want to know that this person can talk through big O notation, and that they can debug problems on a whiteboard with you. We're going to talk more about how to address each of these technical aspects later. But for right now, the tip here to demonstrate problem-solving ability is to have a process, have a system, one of which I'll show you later. I'll show you how I personally like to tackle whiteboard interviews. But you want to have some kind of a process, whether it's a process that you follow and that you came up with yourself, or the AlgoDaily system. You want to make sure you have some way of tackling these problems. A lot of people just jump straight into coding, and that's the worst thing. That's the last thing that you want to do. Second is coding skills. So can this candidate go beyond high-level concepts and actually write code that'll solve our challenges? When people think of technical interviews, this is what they're thinking about. It's the translation of large ideas into working code. And while this is important, I would argue that it's actually second to problem solving. To demonstrate coding skills, obviously, just make sure you're using your strongest programming language, and make sure you're writing pseudocode. I can't stress enough how important it is to write pseudocode. You want to make sure your ideas are well documented, and pseudocode is much easier to switch around, to manipulate, to edit than writing real code. And we'll talk more about that when we talk about the system to solving and tackling these whiteboard interviews. Lastly is troubleshooting. Can you debug a problem? If you get stuck, can you figure a way out? Will you freeze up and just not know what to do? There's been plenty of times where I've interviewed somebody and they'll be doing really well they'll have figured out the overarching idea and strategy to solve the problem. They will probably have written some code at this point, but I'll find a bug and they'll get stuck and they won't know what to do from there. With debugging, you want to make sure that you're really demonstrating that you can step through your code and talk about it out loud. And the biggest tip here is to make sure you're writing test cases that cover all edge cases so you can stay in front of any possible bugs that might come up and foreshadow some of the stuff that might come up so you don't freeze up when you're stuck. Let's talk about the other things, the non-technical things that I might be looking for during a coding interview. We're going to run through the next two slides fairly quickly because I think they should be pretty obvious. These are the so-called fit portions of a coding interview. So let's just run through them quickly. Are they professional? Can I trust you to show up on time, to not say anything outlandish in the office, and to behave like a normal human being? This is very important. Software engineering is a team sport. You have to be able to control yourself and make sure you're professional in the office. And there's not really much to say about that. We like to work with professionals. Secondly is this idea of being growth focused. So is this person going to make my life easier by becoming a better engineer over time? How much handholding are they going to need? So as we talked before, software engineers at large companies have tons of demands, and they won't necessarily be able to walk you through everything beyond onboarding. So it's important that we hire engineers who are able to figure things out for themselves and want to get better. So that wanting to get better is critical. And the last thing that's non-technical that we're looking for is, are you friendly? Are you a nice person? And this sounds very straightforward, but a lot of times you'll have interviewees who are incredibly aggressive. They seem to feel they're entitled to a job. And obviously that's not necessarily the case. You still have to demonstrate that you're a nice person who's friendly, and that I can stand being in the office 8 hours a day with you. This is harder than most people would think to find, and this is also probably one of the easiest things to exude. And two quick things about, will the candidate improve the team? So as I said, software engineering is a team sport. You're definitely going to be working with others. So they're looking for the intangibles on how you might fit in the greater team. So it's not just you and the interviewer working at the company. It's hundreds or thousands of developers with a shared set of principles. So let's talk about mentorship. Will this person be able to teach the team things? Can they mentor junior engineers? Will they be a net asset or a liability? This is especially important if you're trying to get promoted fast. You want to demonstrate mentorship and leadership. So with leadership, can they make tough decisions? Are they going to be able to take charge and lead a project to completion? Because that's where the business value comes from, is being able to take a project from point A to point B. And there's ways to demonstrate that. So some quick tips on how to stand out given that information. The next two sections are actually going to talk about how to display these attributes, but some really quick tips on how to stand out, and some things that I find impressive during a technical interview. So 1, make sure you're asking a lot of clarifying questions. 2, make sure you're writing encompassing tests. And 3, call out edge cases. And I'm not going to talk about these now because we're going to talk about these in the next section, but this is just a preview of what's up ahead. So remember, these are the things that interviewers are looking for. Can you be technically helpful? Can I trust you on the team? And will I like working with you? It seems basic, but if you remember these three things and optimize for these three things, you will most likely be a leading candidate in any of the job search processes. So let's talk about how to exude competency and likability and address the presentation aspect of the interview. So how do you present yourself in a way where they feel that you do exude those attributes and you give them the signals that they want? A big part of it is building rapport with your interviewer. So let's see how we do that. Again, these are the things that you want to demonstrate: technical prowess, professional development and growth mindset, and the ability to work and thrive in a team. This applies to behavioral interviews in addition to coding interviews. Let's chat a little bit about these three things. So technical prowess, we're going to cover it in the next section. Let's talk about how to improve your signaling of professional development, growth mindset, and the ability to work within a team. First, on nerves. So what I have to say about this is everyone gets nervous. Feeling nervous is common and is normal. The interviewer is probably just as nervous as you. Remember, this is a conversation between two strangers who've never met before. What helps with nerves is the realization that everyone gets nervous, both you and the interviewer. If you're nervous, that's completely fine. It's normal. You want to embrace this and you want to use that energy and channel that energy towards a good performance. The interviewer being nervous, that knowledge of the fact always helps out because you kind of go out of your way to make them at ease, which in a way puts yourself at ease as well. You want to try to think of it as a learning opportunity. Just try to have fun with it. Both of you guys are going to be nervous at first, but as the conversation picks up, you'll feel yourself ease up. And anytime you just are overwhelmed, just take a deep breath and just realize that it's a learning opportunity. There's nothing to be lost here. And you can always pick back up where you left off just by saying, sorry, I blanked out for a second. What were we talking about? And that should get you on the right track. Remember, interviewers want you to do well. So if you have a momentary mental lapse, it's totally fine. Just pick up and go back in the game, feeling fresh. A really quick side note on how to prepare for behavioral interviews. So what I would recommend is you find the most common behavioral interview questions. There's an article about this on algodaily.com, and you write stories for each so that during the interviews, if you get asked a question like, name a time you pushed back during a project internally, name a time you had to push back against your manager, or name a time you had to, had an argument with your team lead. How did you deal with it? And you want to write stories for these and arrange them in the STAR method. So situation, task, action, and result, and then rehearse these stories a lot. Again, this presentation isn't really focused on the behavioral interview, but those are some quick tips. So what are some actionable things you can do to exude confidence and competency and really address the non-technical portion, the non-technical signals, which are likability, growth mindset, and all that good stuff. So the first is smile often. This may sound cheesy, but smiling is contagious. There's evidence that it makes you feel good and it makes the other person feel good. If you go into an interview smiling, the interviewer has no choice but to think that you're excited to be there, that you're happy to be there, and it'll naturally ease the tension a little bit. Smiling also builds rapport, so people will associate you with being positive, and that positivity really does carry throughout the interview and gives you a new perspective. Whereas you might have seen the interview as this challenge that you had to overcome, now after smiling and feeling a little bit of positivity, you might see it as just an enjoyable experience. Second, make sure you're listening closely. I can't tell you the number of times I've interviewed candidates and they just kind of zone out. You can tell that they're superficially listening, but really they're in their head. They're thinking, "Oh man, I'm screwing up. I don't know how to proceed. I'm freaking out. What do I do? So you really want to listen closely. This is especially important in the technical portions, and I'll tell you why. To gather requirements properly, which is a huge aspect of ensuring that you're solving the right problem, you need to listen. You need to listen very, very closely. Interviewers will often be giving you hints that you need to absorb, and these hints are critical. In fact, one of the reasons that another reason software companies love using data structures and algorithms questions is because it, by definition, puts the candidate in kind of a underdog state where the hope is you haven't seen that problem before, and they get to see you struggle a little bit. In day-to-day software engineering, there are hard technical challenges that you won't have prepared for, and us giving you hints is a way of seeing if there's an element of collaboration that you can exude if you're a collaborative person. So you want to listen very closely. In fact, you want to listen to their tone to evaluate if the direction that you've taken is good. So as an example, if you hear the interviewer saying, so I see you've used an array. Is there a better way to do it? You might think, oh, this person clearly does not want me to use an array. Let's use a hash map or some other data structure. There's been times where I've seen the interviewee go in a bad direction, and I'll say, are you sure that you want to go in that direction? Are you sure you want to go with that approach? Or I might say, well, what will happen in the long run if you take that approach? What about this corner case? Have you thought about that? And unless you're listening closely, you won't follow any of that. And the third thing is just stay present. And here's a big tip. Stay off your phone in between interviews. So after one round ends and you're waiting for the next person to come in the room, don't go on your phone. What going on your phone does is it provides some measure of comfort. So you're stressed out, you just finished an interview, and you'll reach for your phone and you'll try to check your email or something, text somebody. But what this does is it doesn't really give you space to relax and mentally take a break. You're gonna be shifting gears pretty rapidly. And if you catch yourself thinking about something, you just come back to the present moment. If you catch yourself being bored in between rounds of interviews or feeling like you need some stress relief, instead of reaching for your phone, just take a deep breath and focus on your breath, and don't think about your performance. Stay in the present moment. Go into your senses, feel the clothes on your skin, feel how your posture is, feel your heartbeat. Really go dig deep. And it sounds a little corny, but this actually helps you mentally process all the things that are going on, because it's a stressful situation, and it really helps you focus on the problem at hand. All right, so we're getting to the really, really fun part, which is now you know how to exude confidence, likability, teamwork, and a sense of professionalism. So all the non-technical signals that they want to see. What are the technical things that they want to see? So as I said before, it's not your ability to memorize solutions. Do not try to memorize solutions. The key thing here is to remember they're trying to assess your computer science fundamentals and problem-solving abilities. What does this mean? That just means that you have an approach to solving technical problems. If they hire you, they're going to hand you really tough scaling problems, database problems, distributed systems problems, or really tough UX bugs that you'll need a method to get over. So this is software engineering at its core, is being handed a technical problem and having a system of which you can solve it. Part of which is knowing computer science fundamentals. But also the other part is just knowing the steps you need to take and having a predefined number of steps to take whenever you encounter one of these problems. And remember, keep the paradigm that the interviewer wants to help you out. Make it a collaborative thing. Make it a conversation. Talk through it, knowing that they want to help and that they're willing to help 99% of the time whenever you ask. So one absolute rule is on choosing a programming language. a lot of folks will ask me if it makes sense to learn Python just for interviews, because they've heard that Python is the shortest, least verbose language, and it's easy to fit on a whiteboard, and there's a lot of benefits. It's just very short, it's quick to learn. But do not do this. Don't learn Python just for technical interviews. Always go with your strongest programming language. In fact, I tell students and I tell people I coach, do not use a language that you don't have at least a year of experience in. And here's why. You really need to be able to program under stress. And in order to do that, you have to know all the corner cases of the language. You need to know how generators work. You need to know how iteration works. You need to know all the little edge cases that might come up, how to look up things in hash maps and dictionaries, or even what data structures are available in the language. You never know what's going to come up in part of a language that you might not have mastered. So don't go for Python just because it's short and people tell you to. Go with your strongest language. So what approach do I recommend? Everyone wants to see problem-solving skills, and like I said, it's just the system, making sure that you have a system to solve technical challenges, and having that dialogue and walking through the steps of the system. The system is crucial. You're demonstrating how you'll go into their organization and solve their technical challenges. So a way to do that, whether it's in an algorithmic challenge or whether you're at work solving database systems design challenges, any technical challenge, is what I call the CTB-PO method. And I have a cute way of memorizing this, which is clean the bedroom, paint overflowed. So CTB-PO, clean the bedroom, paint overflowed. And it's a very silly way of it's very silly and mnemonic for memorizing the system, but really what it means is the following. There's 5 steps. C stands for clarify, so clarify the requirements, clarify the problem, really make sure you know exactly what you're talking about. T is write test cases. So test cases are hugely important to prevent issues that come up which might lead you down a bad rabbit hole, or just to demonstrate that you've thought about edge cases. So test cases is number 2, and that's what the T stands for. B stands for brute force. Here, you want to come up with the brute force solution as fast as possible after you've written your test cases. Make sure you're practicing, whether on HackerEarth or AlgoDaily, make sure you're practicing to the point where you're able to come up with a brute force, very, very slow, very inefficient solution as quickly as possible. Typically, you want to be able to come up with a brute force solution in under 5 minutes so that you can spend the rest of your time on the next 2 steps. One of which is P, which stands for seek out a pattern. So the pattern could be a computer science, it could be the introduction of a computer science data structure. It could be a algorithmic pattern. And I'm actually, in the next slide, I'll show you the patterns that you should memorize. But really, after you have your brute force solution, you want to introduce a pattern which is familiar and related to the problem at hand. And then finally, the O stands for optimize. So you want to use that pattern to optimize your brute force solution. And we're going to walk through a sample problem using this system in a bit of time. But for now, remember, clean the bathroom, paint overflowed is the AlgoDaily system for conquering the technical interview. And it's the system for making sure that you're stepping through correctly. So remember, clarify requirements. So ask a lot of questions. Write test cases. When it comes to brute force and coming up with the brute force solution, ask yourself, if I were a machine, if I were a computer, or if I didn't have a computer, how would I do this? What is the most obvious way of doing this? And then with patterns, you'll have to memorize some of the patterns, but there's a finite list of patterns that I'll cover that really gets you about 90% of the way for most algorithm problems. And it usually involves introducing a data structure or using some kind of algorithmic pattern that you would have encountered before. And the last thing is optimized, which obviously makes sense. You want the most efficient solution possible. And some additional things to remember is call out edge cases during the test cases section, and make sure you're talking about runtime complexity at every step. In fact, it's better if you talk about the runtime complexity before they ask you, what is the time complexity? What is the space complexity? You want to make sure you've already addressed that. So I told you in the last, just a moment ago, that I would tell you what patterns address maybe 80–90% of the problems you're going to see. And these patterns all have guides of their own on algodaily.com. So take a look. The 2-pointers and sliding window patterns are incredibly valuable for strings and arrays. The use of hash maps for lookups. Obviously, you want to use hash maps as much as possible whenever you encounter problems where it's like we want to iterate through an array and store this information about each element. Hash maps are great in those cases. Similarly, fast and slow pointers for linked lists. Anytime you want to detect a cycle, fast and slow pointers should be your default. Node manipulation. So this means just being able to swap nodes in a linked list or in a binary tree. Make sure you really have figured out how you can do the swaps correctly. Binary search is great for anytime you need to traverse an array or a list very quickly. And then the next 3 come up almost every interview where there's trees or graphs. Breadth first search, depth first search will be the traversal method for, I would say, 80% of trees and graph questions and k-way merges. They're not going to ask you about Dijkstra's algorithms. They're really going to ask you, basic BFS and DFS traversal. So make sure you really have that down. Remember, depth first search, in order, pre-order, post order. Just memorize those and make sure you know why and when to use pre-order, in order, and post order. And with breadth first search, make sure you've mastered how to use a queue, or make sure you know how to use a queue with breadth first search. And then with memoization and recursion, just always have those in the back of your hand, in the back of your mind. Memoization to speed up any kind of problem where there's subproblems that are repeating frequently. And recursion is just great to know. And just make sure with recursion problems that you're writing the base case first before going into any other aspect of the problem. So I just ran through these patterns really quickly. Obviously, we can talk about these patterns all day. There's guides on algodaily.com again, if you want to dive deeper. So let's use this system to solve a problem that comes up, I would say, fairly often with technical interviews. So it's the threesome problem. So I'm going to read it really quickly, and then we'll talk about how to use the clean the bedroom, paint overflow method to solve it. So here's the sample problem. Given an array and an integer value, find if there is a triplet or 3 numbers in the array whose sum is equal to the given value. If such a triplet is present, then print it and return true. Otherwise, return false. So how do we solve this? Let's use the system that I just outlined to demonstrate that we have problem solving ability. So here's how we'd solve this using the approach outlined, which I highly recommend. So first step, we would clarify the requirements. So we would ask the interviewer, are there only integers in the array? Are the numbers sorted? How many numbers are there? And what is the range of numbers? And really, you're trying to get to the core of the problem. A lot of the times, hints to the solution will actually be revealed as you talk through these requirements. For example, if they say that the integers can be negative, you might not be able to use the strategy that you were originally going to use. And asking questions and clarifying requirements helps you a lot in picking up the conversation and making sure you're making a dent in the problem. A lot of people will just jump right into coding, but if you haven't fully understood the problem and you haven't asked these clarifying questions, you're going to start coding up a solution that might not necessarily take into account all the things the interviewer is looking for. Clarifying requirements is something that very experienced software engineers do, and so it's important to do that. Then you want to write out your test cases. So here I've written out 3 sample test cases, and you want to just make sure you have these test cases on hand, and also make sure that you have a case where you might return false or null. So in this case, I have in the last test case, which is an example of there being an array where there are no triplets that add up to the sum. And you want to ask the interviewer, in that case, do we return false? Or can we be sure that there's always going to be numbers that add up to the given value? So then after that, it's time for the brute force solution. So the brute force solution is typically, what is the most obvious way to do this? How would you do this if you just started programming or if you did not have a computer? And so in this case, the brute force solution would be to generate all possible triplets in the array. So it would be probably a triple nested loop. And you want to generate all possible triplets and compare the sum of every triplet with the given value. And then you want to talk about the runtime efficiency, which is O of n to the third. And you want to acknowledge that this is very slow. Next up is the pattern recognition. So if you've done enough problems, if you've gone into the list of patterns that I talked about in the previous slide, which I'll show again later, you'll have realized that, hey, I've seen this problem before. I might have done the two-sum problem before, or I might realize that the most efficient way to look up, to store and look up things like this, like a count, or whether things sum up to something, is using a hash. Or I've seen two-sum get sorted, and I've seen the two-pointer approach. So here you're reaching in and you're looking for a pattern from your past experience, something that you can apply to this problem. So as I said before, here we might have done two-sum before. We might know about the two-pointer pattern, or we might know that hash maps are the most efficient way to look things up and store things. And with that, we can then use that pattern to optimize for the problem. So we would say, hey, I think this feels like the two-sum pattern. This feels like the two-sum problem. What if we just iterated through each element and then ran the two-sum solution for each of these numbers? And that would be the most efficient solution. And you would get something in O of n squared time, which is not fast, but it's faster than O of n to the third. And at this point, you would have gone through each step, and the interviewer would have seen that you have a system of getting through these kinds of problems, and that you'll likely be able to replicate the use of that system when you're actually at work. So real quick, to wrap up, a final checklist. Here are the things you should actually memorize. Remember when I said they're not looking for you to memorize solutions? Here's the things you actually should memorize. If you forget everything else, remember these things. First, get to know these patterns. Two pointers, sliding windows, fast and slow pointers, hash maps for lookups, node manipulation, meaning the swapping of nodes, binary search, BFS, DFS, K-way merge, memoization, and recursion. You want to make sure you're smiling, listening, and stay present. So accept the feelings of doubt, accept that nervousness, and try to have fun. Pro tip, use we instead of I when you're asked about team-based questions, and vice versa. When you're asked leadership questions, you want to use I instead of we. And make sure you're noticing the difference. And make sure you're building rapport with your interviewer. They want you to do well. Make sure you take that away. Interviewers want you to do well. So make it a conversation and ask for plenty of hints. Make sure you're following an approach. So whether you use the method I just outlined, the CTBPO method, or some other approach, make sure you have some kind of a system to tackle the problem. So again, the CTBO method, clarify the requirements, write test cases, come up with a brute force solution, reflect on a pattern, and optimize the solution. So memorize the approach, memorize the coding patterns, and try to memorize the data structures and their time complexities, because they will come in handy. And just make sure you keep practicing every day and do lots of mock interviews. Thank you very much for tuning in to this webinar. I hope you've gained a lot about it. You can, before I wrap up, does anyone have any questions? I actually have not opened the question chat. So let's answer some of these questions. Can you please share the slides after the presentation? Yeah, so HackerEarth will be making this presentation available for after we wrap up. It'll be on YouTube and Vimeo. I think HackerEarth will provide more details about where you can find this webinar recorded, but it will be available. Some other questions. What's important to prepare for product-based companies? For product-based companies, it's the same exact things that they're looking for. Typically, with product-based companies, I've noticed that there's more of a focus on UX. So really, like, how will users think about our product? What do you think users will want in our product? And how should we design the product so that it maximizes the user experience? So to answer that question, I really think it's just everything we've talked about today, but you might also want to prepare for some more UX related things. Let's see. Aman asks, how to excel at data structures. If I have 3 months of time for interviews, is there a specific path in order to be very good at data structures and algorithms? So I'm gonna, plug AlgoDaily here. I think AlgoDaily's course is designed to be just about 2 to 3 months long. Right now, we offer the course in 2 different ways of purchase: a monthly subscription or a 6-month purchase. But I think the course does a really good job of walking you through the data structures and walking you through the algorithms and the patterns. We really try to make it as visual as possible so that you're not intimidated by any of the material. So I would say go on algodaily.com, check it out. HackerEarth also has a ton of great material, so check that out too. Okay, awesome. A ton more questions, great. Let's see. What should I do if I know how to solve the problem but not be able to write code? If you know how to solve the problem but you can't write code, write pseudocode. I told you, as I said before, problem solving ability is much more important than, well, I wouldn't say much more important, but problem solving ability is more important than being able to write and implement the code. We can teach anyone syntax, but we can't teach anyone to really think big picture and really solve these problems on kind of a computer science fundamentals / mathematical manner. So if you can't solve the problem but know how to write code, but if you can solve the problem but you're not able to write the code, write pseudocode, write it in English, and then try your best to convert that into working code. But if you can't, pseudocode is still better than nothing. Let's see. We have Susmita, I believe, who's asking, what about math questions? So, for example, the binomial theorem. I have encountered math questions before in interviews, and honestly, in those cases, it's very much hit or miss, unfortunately. With math problems, you see them more often with kind of DevOps roles where they deal with latency and number of servers and things like that. If you encounter a tough math problem that you can't solve, I would say, at that point you have to be honest and say, I have never studied this area of math, but here's what I think might be the best way forward. And just remember, keep it a conversation. If you truly have no idea how to get started on the math problem, you have to let them know, otherwise you're gonna look silly. But if you have somewhat of an idea, tell the interviewer that you have somewhat of an idea and see what they say. They might move on to a different question that you actually have a chance at solving, or you can say, I don't know this subject of math, but but here's how I think we might be able to go. So something's better than nothing, but math problems are tricky. Books I would recommend. Cracking the Coding Interview is great. Elements of Programming interviews is great. For people who like visual learning, grokking the algorithm, I think it's called grokking the algorithm, is very good. It has a lot of pictures. AlgoDaily.com, if you want to count that as a book, has tons of visuals and ways to really see the pictures. See the problems. So yeah, those would be my recommendations for books. Sorry if I'm talking fast. I'm just trying to get through as many of these questions as possible. If Shang Lin Chen says, if you already realize the pattern, should you still go through the brute force solution or just go straight to the pattern and optimization? So this is a great question. If you know the solution, you still want to go through the process. And the reason is we're not looking for the solution. As I said, interviewers are not looking for you to memorize the solution. They're looking for you to know a way to solve the problem. And so even if you know the solution, you still want to go through the steps and say, here's the test cases, here's what the brute force would look like, because it shows that you can think through other solutions. We don't care if you can solve this particular problem. We care if you can solve general problems. Anil says, how to go when you're not able to come out with any progress in the question? I think, like I said before, you have to demonstrate something. So just keep it a conversation and say, here's what I got. I'm stuck. I'm really stuck. Here's, can you give me a hint? Don't be afraid to ask for hints. What do you focus on for Google telephone interviews? I actually have a section on algodaily.com that talks about problems that people on Glassdoor have seen with regards to certain companies. I can't guarantee they're 100% accurate, but go to algodaily.com/companies, and there's a list of what from Glassdoor appears to be a list of common questions, and links to AlgoDaily challenges that are very comparable. So I would say start there. Dynamic programming, how important is it? I would say it's pretty important just to know how to do it. I personally actually haven't seen them that often. Most interviewers nowadays realize that dynamic programming is very, very difficult and intimidating. They come up more often as you level up. But really, dynamic programming can be reduced to just caching subproblems and then using those cached answers to continue to solve the greater problem. So focus on memoization. There's a bunch of great resources on Medium for dynamic programming. So I would say, yeah, just go online. It is fairly important. You'll probably see it in maybe 1 out of 10 to 15 interviews you do. But it's always great just to know for software engineering. Let's see. More questions about books, which I addressed. How to prepare for Python interviews. How's the CTBPO method applicable here? With language-specific interviews, you pretty much just want to memorize documentation. If you type in Python interview questions or Java, for example, AlgoDaily has a great JavaScript interview questions section. It will cover the strategies and the things you need to know. Usually the questions involve syntax, so just try to memorize as much of the syntax as possible for language-specific interviews. The CTBPO method isn't as applicable for language-specific ones. It's more for algorithmic problem-solving questions. But for language-specific ones, just Google, and AlgoDaily has a good JavaScript interviews specific questions article. And we're going to add Python and other languages too. HackerEarth also has amazing resources for these language-specific interviews. Mock interviews, yeah, mock interviews are a must. Make sure you're doing mock interviews. I would say as much as once a day in the week to 2 weeks leading up to your interview. Just go on pramp.com or go on AlgoDaily or HackerEarth, get a problem, and just find a friend. And just mock interviews are crucial. It's the only way to emulate and practice the things we talked about today. How many algorithms should we practice per week? I'd say 1 a day. Yeah, AlgoDaily. Yeah, 1 a day is perfect. I've addressed language. Matthew Lee, can we use the same approach for system design questions? Yes, you can. Make sure you're clarifying the questions. You'll probably skip the test cases for system design interviews. And let's see, there's no brute force solution, obviously, but clarifying for systems design, it's the same clarifying requirements, really making sure you understand the problem. And then instead of test cases, start talking about components. Modularize your application, start talking about what things are involved. But really, it's the same concept. Take the problem, break it up, gather requirements, and try to solve the subproblems. Thank you so much. Let's see. Is AlgoDaily hiring for a junior dev position? We are not. We are not. If you would like to contribute to AlgoDaily, reach out to me. team@algodaily.com. We are always happy to get contributions. I'm actually happy to provide some AlgoDaily premium content or pro content. If you help contribute and build out the curriculum, we're really trying to make it the best place online, aside from HackerEarth, of course, to prepare for coding interviews. But yeah, would love help. All right, I think we are over time at this point. It looks like most of the questions are a repeat of what I've addressed before. If any of the HackerEarth guys have anything that they want to say, otherwise I think we're done for today. So thank you so much for joining.
Thank you, Jake, for your time. It was a great session.
Thank you so much. All right, I'm going to end the webinar. Take care, guys. Thank you so much. If you have any more questions, feel free to reach out, team@algodaily.com or algodaily.com. And be sure to check out hackerearth.com. There's tons of great material there. And HackerEarth, thank you for being great partners with me and AlgoDaily so far. Thank you.
Thank you, Jake.